This is Miss Sebastian, and we're going to look at probability and combinations and permutations. So our first problem is solve 7 combinations of 4. So when we look at this, we're going to remember that 7 factorial is what we need to figure out how many different combinations of 7 that is. And that's 7 times 6 times 5 times 4 all the way down to 1. But because it is combinations, okay, and we're looking at 4, we're going to go 7 times 6, and we're going to count down 4 places. So 1, 2, 3, 4. It just so happened to end on 4. It does not always act that way, but you're going to count down 4 spots. And because order does not matter, and what that means is you could have blue, green, and green, blue, and it will still be the same thing here. Because when you throw those M&Ms in your mouth, a blue, green will taste the same as a green and a blue. Okay, so because of that, this permutation at the top, which is 7 times 6 times 5 times 4, will be divided by the factorial of this number, the 4. So we're going to say 4 times 3 times 2 times 1. So all I'm going to do is multiply the top. So 7 times 6 times 5 times 4. And I get 840 for the top. And on the bottom of this division, I've got 4 times 3 times 2 times 1. And that is 24. So to figure out how many combinations I can make with 4 somethings out of 7, I'm going to go ahead and divide those. 840 divided by 24. And because order doesn't matter, I can make 35 combinations. So again, what we did, we look at this number here. That is what we start with right here. Then we count down 4 spots. So 7, the next number down is 6, then 5, then 4. That's 4 numbers here on this line. Because it is combinations, we divide by the second number, which is that 4 here, factorial. So that's here. So if this had been, let's say, 8 combinations of 3, we would say, okay, I'm going to start with 8, and I count down 3 spots. So 8 times 7 times 6, that's 3 spots, 1, 2, 3, and divide by this number, the factorial of that, which means 3 times 2 times 1. So I'd multiply that out and get my answer. You can do that for any sets of those combinations. Which of these is not a combination? Now before I told you combination is where order does not matter. So would it be ways to choose 4 or 5 books? Ways to choose 4 of 9 books? 9 colors. First, second, and third prize winners will be selected, or 3 types of nuts will be selected to go into a snack mix. The only one of these that order does matter is first, second, and third place winners. Okay, so that one is not a combination. That would be a permutation. A permutation. How many ways can you choose 2 dishes from a menu of 8? So this one, we're going to make our own combination. It's a combination because order does not matter. I'm choosing 2 out of 8. So I'm going to say 8, and I'm going to count down 2. So that's 1. There's 2. Divided by the factorial, 2 times 1. The factorial always comes from this number and counts down to 1. So 8 times 7 is 56. 2 times 1 is 2. So those combinations, I can make 28 different combinations. If choosing 3 players to represent the team at a fundraiser, okay, is that a permutation or a combination? So if you're choosing 3 players out of the 12 that are on the team, that order does not matter. So combination, order does not matter. And the permutation, the order does matter. So if you're choosing 3 at random to represent the team, order does not matter. This would be a combination. Okay, now we're going to look at solving 5 permutations of 3. So that means combinations of 3, but the order does matter. So when we did 5, count down 3 times, 5 times 4 times 3, this time we don't have to divide by anything because the order matters. So all you have to do is 5 times 4 is 20, times 3 is 60. So 5 permutations of 3 would be 60. We could do the same thing if we had 7 permutations of 5. We would count down 5 spots, 7 times 6 times 5 times 4 times 3, and we could multiply that out and get our answer. How many different ways could you arrange 6 books on a shelf? So this one, order does matter. So we're going to have to do 6 times 5 times 4 times 3 times 2 times 1, because this would be 6 factorial. So when I multiply these out, I get 6 times 5 is 30. Times 4 is 120. 120 times 3 is 360. Times 2 is 720. Times 1 does give us that 720 ways. Is choosing 4 pizza toppings from a list of 8 for your pizza a permutation or a combination? So a permutation, order matters. Combination, order does not matter. So for 4 pizza toppings out of 8, they're all going to be just tossed on your pizza in any order, so order does not matter. That would make this one a combination. How many different ways can you choose frozen yogurt toppings from 20? So 20 frozen yogurt toppings in combinations of 6. Order does not matter because they're going to be sprinkled all over your yogurt. You're going to say 20, and you're going to count down 6. 20 times 19 times 18 times 17 times 16 times 15. So then all you're going to do is divide by 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. So 20 times 19 times 18 times 17 times 16 times 15 gives us 27,907,200. And 6 times 5 times 4 times 3 times 2 times 1 gave us 720. So now we're going to divide those two. If you're doing it in your calculator, you could probably just type it all in at one time. But we do get 38,760 ways that you can choose those frozen yogurt toppings.